Total internal reflection. Let us consider a ray of light passing from glass to air, that is, from a denser medium to a rarer medium. When a ray of light is incident on a refracting surface, a major part of the incident light is refracted and a small portion is reflected. The refracted ray bends away from the normal after refraction. That is, the angle of refraction R is greater than the angle of incidence I. Now, if we increase the angle of incidence, the angle of refraction also increases. And for a certain angle of incidence, say IC, the refracted ray grazes over the surface of separation and the angle of refraction will be 90 degrees. IC is referred to as the critical angle. Critical angle is that angle of incidence for which a ray of light while moving from a denser to a rarer medium just grazes over the surface of separation of the two media. That is, the angle of refraction is equal to 90 degrees. If we further increase the angle of incidence, the light ray, instead of getting refracted, bounces back into the same medium, obeying the laws of reflection. This is known as total internal reflection. Conditions to be satisfied for total internal reflection to take place are: the ray of light must travel from a denser medium to a rarer medium. The angle of incidence must be greater than the critical angle for those two media. Effects of total internal reflection. Total internal reflection is the reflection of light that occurs when it strikes an interface at an angle of incidence greater than the critical angle for the pair of media. Let us now discuss some of the effects of total internal reflection. Mirage in deserts and sparkling of diamonds are some of the effects of total internal reflection. Mirage in deserts. Mirage is an optical illusion seen very often in deserts, due to which an observer sees inverted images of distant objects. The observer thinks that the inverted image of the far-off object is the reflection of the object in water, although no water exists there. Let us see how this happens. In deserts, as the sand gets heated, the lower layer of the air becomes very hot, and the upper layers are comparatively cooler. A light ray coming downwards from any object passes through layers of air of gradually decreasing density. At each layer, refraction takes place and the light ray bends away from the normal. The angle of incidence continues to increase until at a certain layer the ray is incident at an angle greater than the critical angle of the air with respect to the next layer of air. At this interface, the light ray suffers total internal reflection and proceeds upwards from the rarer to the denser layer of air. The whole path of the ray is therefore concave as shown here. Due to this, the observer will see an inverted image of the object. The observer thinks that there is a pool of water from the formation of image. A similar phenomenon is observed on roads on hot summer days. It is due to total internal reflection that the surface of hot tar roads seem to be wet and shiny. Sparkling of diamonds. A diamond sparkles as the rays of light suffer total internal reflection at its various faces. Let us see how this happens. The critical angle for the ray of light traveling from diamond to air is very low, about 24 degrees. Therefore, most of the incident rays suffer total internal reflection. Moreover, the diamonds are usually cut with their faces in such a way that once a ray of light enters it, it suffers total internal reflections at various faces before it has any chance to emerge. Whenever the angle of incidence at any face is less than 24 degrees, the light comes out from it and the diamond appears to be bright. Thus, a ray of light on entering a cut diamond literally gets trapped within it for some time and causes it to sparkle.